Okay, this is a special case for solving linear systems using substitution method. This is special case 1. So I'm going to do a couple of these. Alright, the first thing again, like I talked to you before, is we want to solve for x, so we won't get x equal by itself or y by itself. It doesn't matter. We just have to solve for one. And if we look at equation 1, there is a variable with no number on it, and that's the one we want to solve. And so I'm going to go ahead and solve for x in equation 1. So here we go. X minus 2y equals 3. I'm going to add 2y to both sides. And when I do, I have x equals, this becomes a zero pair, and it's going to be 3 plus 2y. So this equals x value. Now I'm going to take this and I'm going to plug it into the other one. So here's my other equation, and I'm going to take the x and I'm going to plug it in here. So it's going to be 2, and then we're going to multiply 3 plus 2y, and then we have to subtract y, because remember this right here goes right here, and that equals 6. Now we're going to follow what we call the distributive property. We're going to multiply 3 times 2 and get 6. Then 2 times 2y to get 4y, and then we got to subtract 4y and we get 6. Now if you notice this right here, these one's a plus 4y and the other's a minus 4y. Well, that equals 0. So we have 6 plus 0 equals 6. And 6 plus 0 really is 6. So 6 equals 6 is what we came up with. We have no more variables, and because of this, this is a special case. Now there's a way to remember this. Does 6 equal 6? And the answer is yes, it does. So whenever the one side equals the other with no variables, we know that since they're the same number, then they're the same line. And if they're the same line, what we're saying is we have a line that's something like this, and then we have another line exactly the same, which will be on top. This is the special case, the infinite set. Alright? So you would write the infinite set on here. Alright? And there's many ways to write this. You could write the little with the circle through it. Oh, I'm sorry, that's the wrong one. My fault. I'm thinking of something else. You could do the what I call the double bar R for all real numbers, okay? Or we could say it's the infinite set. You can say it's the infinite set, okay? I'm trying to erase this so we can show you a little better. So it's same line, same number, same line, and if, like I said, if it's the same line, same line, then and we're going to write this again now, so we can say it's the infinite set, which is all real numbers. That's a double bar R. So that means they touch an infinite number of times. This is one of the solutions for one of the special solutions.